Hello, welcome to lesson 8 on the topic Permutation Combination. If you remember, in lesson 7 we got introduced to the concept of permutation and we had closed by learning a very important concept. N different things can be arranged in a straight line in n factorial ways if there is no other condition. Okay, let me take you further to the applications of permutation. Alright. Now what I am going to do, children, is I am going to take a standard set of data, and using that data I am going to share different questions with all of us. Alright. Please listen carefully. Suppose we have 5 boys and 5 girls. They are to be arranged in a straight line. Okay, there are 5 boys and 5 girls. They are to be arranged in a straight line. I'll take different questions and try and share it with you. Okay, the first one, number of ways if there is no condition. If there is no condition, obviously we are talking about arranging 10 people in a straight line. If there is no condition, the number of ways is straight and simple, n factorial, 10 factorial. Okay, alright. The second one, boy at one end and a girl at the other. Boy at one end and a girl at the other. So now this question cannot be done directly. Why? Because you have an additional condition. We need to have a boy at one end and a girl at the other. Please listen carefully. So what we will do, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Correct? What we will do, we will first satisfy the most important condition in the questions. Right? So here we need a boy. A boy can be selected for this place in 5C1, that is 5 ways. Alright? A boy can be selected for this place in 5 ways. After doing this, a girl can be selected for this place in 5 ways. So a boy can be selected in 5 ways, a girl can be selected in 5 ways. Alright, let me put these values here. So boy in 5 ways, a girl in 5 ways. Does the question say that the arrangement should start with a boy and end with a girl? No, the question does not say that. That means, can they interchange their positions? Absolutely. I hope you are understanding. The boy and the girl in this question, they can interchange their positions. So again multiplied by 2 ways, it will become double. Okay. Now, have we fulfilled the most important condition? Yes, we have done that. Okay. How many people are already seated? 2 people are already seated, a boy and a girl. How many people remaining? 8 people. Do they have any condition? No. Now you can directly apply 8 factorial. Simple. Okay. So what is the rule? The rule is first fulfill the most important condition. So a boy can be selected for this place in 5 ways. A girl can be selected for this place in 5 ways. They can also interchange their position. So 2 ways. What about the rest? 8 factorial. Simple. Alright? Okay. Now, third example. All the boys are together. Now, please understand, children, even though the data set is the same, we are actually discussing different questions. So, don't presume that we are discussing one question. They are all different questions. They can get into different competitive exams. Papers of different competitive exams, different questions. Okay, so all the boys are together. Now this is very interesting. All the boys are together. You will get these these type of questions very frequently because they are popular. All the boys are together. Now, what is the concept? Please understand. What we will do, we will take all the 5 boys as one group. Alright? We will take all the 5 boys as one group. So they are not 5 boys, it is one group. And then we have 5 girls. Okay? So how many things do we have in total? 6 things. Right? We have 6 things. 5 girls and a group. 6 things. Now 6 things can be arranged in a straight line in 6 factorial ways. Right? 6 things can be arranged in a straight line in 6 factorial ways. And so into. For each of these arrangements, the boys can get rearranged amongst themselves. Now this is interesting. For each such arrangement, in each such arrangement, the boys can get rearranged within themselves, within this group. And that can be done in how many ways? So 5 boys within the group can be rearranged in 5 factorial ways. So what will be the correct answer? 6 factorial multiplied by 5 factorial ways. So this is another question. Whenever you get a question where the question talks about all things being together, you will always have to use this thought process. Okay, so 3 different questions. Total number of ways, no condition. Boys at one end, boy at one end and girl at the other, right? All the boys are together. What else? Okay, so let me take out this particular part, these 3 parts of the question. I hope you have understood what we were trying to do. Okay, right. Now let me give you another example using the same data. Okay, so part D. All boys are together and all girls are together. All the boys are together and all the girls are together. Correct? An additional condition. So now what we will do? We will take all the 5 boys as one group. We will take all the 5 girls as one group. So now you don't have individuals, you have 2 groups. So first of all, you think about arranging these 2 groups. These 2 groups can be arranged in 2 factorial ways. Yes, very good. One group of 5 boys, one group of 5 girls. So 2 groups in a straight line, 2 factorial ways. Now, the boys can get rearranged amongst themselves in how many ways? 5 boys, remember, 5 boys within this group. Within this group, they have to get rearranged. So 5 boys within this group, 5 factorial ways. How about the girls? Yes, what you are thinking is absolutely right. The girls also can get rearranged amongst themselves. So how many ways? 5 factorial ways. Right? So what will be the correct answer? 2 factorial into 5 factorial into 5 factorial. Correct? Okay. Now let me give you no 2 boys are together. Let me share this one with you. No 2 boys are together. Children, I hope you are listening to me very carefully, because this is a beautiful example of a question that is very popularly asked, mainly because most of the children will make a mistake. Alright. Now let me, before I tell you this question and how to do it, let me tell you how to differentiate this question from another question. You know, what many people do, they think that this is the question where you have to take all the boys together, you have to take the total number of ways, and from the total you have to subtract all boys are together. No, I'm sorry, your thought here is not correct. What is this question saying? This question is saying that no two boys should be together. Alright? This question is not saying all boys should not be together. This question is saying no two boys are together. How to approach such questions? What we will do, and I hope you are listening very carefully. What we will do, we'll first arrange the set which does not have any condition. So we'll first arrange the 5 girls. Alright, we'll first arrange the 5 girls. Now when we arrange the 5 girls, they can be arranged in 5 factorial ways. So 5 girls in a straight line, 5 factorial ways, fairly simple. Now what happens? When these 5 girls are arranged, there are 6 places created for the boys. When these 5 girls are arranged, there are 6 places created for the boys. Okay? And the boys can occupy any 5 of these 6 places. If the boys occupy any 5 of these 6 places, you can clearly see that no two boys will be together. Okay? So 6 places for the boys, and how many boys are there? There are 5 boys. So the first place can be, the first boy can occupy a place in 6 ways, the second boy in 5 ways, the third boy in 4 ways, the fourth boy in 3 ways, and the fifth boy in 2 ways. So what is the answer? 5 factorial into 6 into 5 into 4 into 3 into 2. Now let me tell you children, this part 6 into 5 into 4 into 3 into 2 can also be written as 6p5. Can also be written as 6p5. So many times the answer to this question is also presented like this. Don't look only for this option. It could be written like this also. So 5 factorial into 6p5 is the same. Let me tell you another thing. 6 into 5 into 4 into 3 into 2. What is missing to make it 6 factorial? Only into 1. And into 1, whether it is there or not, does not make any difference. So this part can also be written as 6 factorial. And therefore, the answer to this question can also be written as 5 factorial into 6 factorial. Alright, so this is a beautiful example, but towards the end, let me tell you, the answer can be presented in 3 different ways. It could be presented as 5 factorial into 6 into 5 into 4 into 3 into 2. It could be written as 5 factorial into 6p5, or it could be written as 5 factorial into 6 factorial. I hope you have understood many questions of permutation. Thank you.